guys, my name is Michael and welcome to a new GTK tutorial. In this tutorial we are going to move on with our GTK toolbar and we are going to check the other signals remaining. Until now we saw how the style changing signal works. Now we have another three signals. The first one is the focus, home and as you can see, a KME signal used internal by GTK, so which means the signal can be used in application code, which means we are not going to work with it. Instead we have the orientation changed and the pop-up context menu. So let's see how those two works. Anyway, the orientation changes says emitted when the orientation of the toolbar changes. What exactly means? When I let me compile and run the program, as you can see now the orientation is left to right, which means it's the horizontally. So basically this is default, but you can change this behavior. I'm going to show you how in a second. That being said, let me call the G signal connect swap on the toolbar and the orientation change it. G callback, let's say orient callback, and again the toolbar. Now let us create this function. The signal signature of the function it is as you can see void and should take at least two arguments or three if you use gsignal connect. We are using two because of the swap. The first one is the toolbar and the second is the orientation. So how it's working you will see in a second. Static void orientation callback GTK toolbar, and the second one it should be like documentation says GTK orientation. Now let's see how you will create it. Well, basically first thing first, G return if fail, GTK is toolbar, and now I'm going to say if the orientation it is equal to GTK orientation horizontal, where is it? Nope, not there. I hate when these things happens. Again, let me fix it. So now we are going to say gprint the orientation change to horizontal, else if it's not, then the orientation change to vertical, isn't it? Now let me format it, let me compile it and run it and see what happens. At this point we have nothing, and that happens because we do not have any changes of the orientation, but this behavior we are going to fix it right now with the help of GTK orientable set orientation. GTK orientable our toolbar, and of course now I'm going to say GTK orientation vertical. So I'm going to change it to vertical. Before I call this before we compile and run the program, let us see what's the story with this function, just to give you a short brief about it. Okay, it is a little bit complicated, it doesn't find it, so let's see if it finds now. Okay, doesn't have too much, but on the changes, let me see where exactly it is, right here, and we got it, isn't it? So GTK orientable set orientation sets the orientation of the orientable, okay, the parameter, so you don't have too much information. But the GTK orientable, it is basically an interface for flippable widgets. It has only two functions, as you can see, the GTK orientable set and GTK orientable get. Okay, so it's not too much. The GTK orientable interface is interpreted by all widgets that can be oriented horizontally or vertically. So for historical reasons, such widgets have been realized as subclasses of common basis class, for example GTK box, whatever. We have here a lot of things. GTK orientable is more flexible in that you that it allows the orientation to be changed at runtime, which is very good. The thing which we are basically doing right now, we make this possible at runtime. Now let me compile it and run it. You see the orientation changed to vertical. As you can see, now the buttons are verticals. When I said we do it now at the runtime, I meant if, for example, you create a button, you click the button, and in the click it callback you set this function, then it means it gets set on runtime. Okay, so that being said, basically this is how orientation change works. Now let's see what's the story with the pop-up context menu. It says a function, a gboolean function, which takes 1, 2, 3, 4 parameters, 5 if you work with gsignal connect, but me, I'm working with gsignal connect swap in this example, emitted when the user right clicks the toolbar or uses the cabling to display a pop-up menu. Application developers should handle this signal if they want to display context menu on the toolbar. So the context menu should appear at the coordinates given by the X and Y. The mouse button number is given by the button parameter. So if the menu was powered on using the cable button is -1. Okay, so let's see. It is the toolbar, it is the X, the Y, the button, and the user data. So let us work with this. I'm going to copy, and I'm going to make a new call, okay, like this, just to be sure that it is in different place. So on the toolbar we are monitoring the pop-up context menu, so I'm just going to say pop context callback, wherever. Okay, now let us create this function. Static, it said gboolean, you see, so we need to provide the same one. Now the first one should be the GTK toolbar, and then we have X and Y, gint X, gint Y, and then we have the gint button. Now the user data we don't need, because like I said, we are working with gsignal connect swap, so we are swapping this one with this one, which means one is enough. Now the thing here is that the first thing first, we are going to check. I'm going to copy this one, g return if fail, and now let's see, g print x %d x, and now y, and of course the button, which is the button. You will understand in a second exactly what happens here. Now watch, I'm going to compile and run the program. Okay, let's see which mistakes did return. Yes, of course, sorry guys. Return GTK event propagate. I'm going to return false. So yes, my bad. G return if val failed. Here is the problem, which it tried to. So we need to return something. So I'm going to say GTK event, GTK, sorry, GTK event stop. Basically, stop, this one means true here, and this one here means false. Okay, now let me compile it and run it and watch what happens when I'm going to use my right click. You see, at this position in the middle I got X at the position 672, Y is at 329, and the button was 3. Now if I'm, for example, clicking right here at the top right corner of the button, now we have 604, 289, and if I go here we have 982. So basically these coordinates are those coordinates which you gave it to your menu, so that the menu knows exactly where should appear. Not because if you are right clicking right here and you are expecting the menu to come in this area, should come here and not in other place, and this is very helpful about having this information. That being said, thank you guys for watching. If you like it, please subscribe, share with your friends and neighbors, and until next time, see you guys.